So we're looking at an algebra equation that Jessie was asked to solve, and she has shown her step-by-step solution. Now, is her solution correct? What we should do is substitute her solution, -2, into the equation to see if it works, if it does give us a value of 1. So 4 times the quantity, we have -2 plus 3, and we want to know if that equals 1. Well, -2 plus 3 is 1. So 4 times 1 is 4. Does that equal 1? And it absolutely does not equal 1. So Jessie's solution is not correct. So number 2, if it is correct, justify each step. Well, it's not, so this question is not apply to us. Number 3, though, if it is incorrect, correct her solution and explain what she did wrong. Well, let's look at her steps first. When we see parentheses, our first step is we should distribute. So 4 times x plus 3 equals 1. We want to distribute the 4, and that would give us 4x plus 12 equals 1. So already right there, Jessie made a mistake. She did not distribute the 4. But I don't think that was her only mistake. As I look on her last 2 steps, if 4x is equal to -2, then certainly x cannot also be equal to -2. So she just kind of ignored the 4 rather than divide it on both sides. Okay? So she actually made 2 mistakes. She forgot to distribute the 4, and then she didn't divide both sides by 4 either. She just erased the 4. So for us to fix this, to see what the real solution should be, we're back over to 4x plus 12 equals 1. We need to subtract 12 on both sides. So 4x is equal to 1 minus 12 is -11. And then to isolate the x, we divide both sides by 4. So x is equal to either -11 fourths or -2.75. All right, numbers 4 and 5, we have 2 word problems to do. We love these. So all word problems, we will start with our let statement. So we need to identify what is it that is unknown in this problem. So Jade is stranded downtown with only $10 to get home. A taxi will cost her 75 cents per mile, but also a flat fee of $2.35. Okay? So 75 cents per mile and $2.35 flat fee. We want to know how many miles can she travel with her money. So let x be the number of miles. Okay. Now, every mile she travels will cost her 75 cents. So 75 cents times the mileage x. But we have to remember to add on the $2.35 hire charge, the flat fee. And she only has $10 to get home. So this better equal $10. Well, let's solve it and see how far Jade can go. First, we'll subtract the $2.35 from both sides. So once she's paid her flat fee, she will still have $7.65 remaining that she will use to pay for her mileage, 75 cents per mile. If we divide both sides by 0.75, x is going to equal, now this probably will not come out perfectly the way you would imagine, but 765 divided by 0.75 is 10.2. So technically, I guess she could go 10.2 miles. If they charge only by whole miles, then another acceptable answer would be that she could only go 10 miles. All right, number 5, Jasmine's dad is planning a surprise party for her. He's going to get a bouncy castle and provide food for all the guests. Now, the bouncy castle costs $150. The food is $3 per person, and he has a budget of $300. Okay, so how many guests? What is the maximum number of guests that her dad can invite? Well, let X equal then guests, her maximum number of guests. How are we going to spend this $300? Well, we're going to rent a bouncy castle, plus we're going to get food and hope to keep that at our budget of $300. Well, the bouncy castle is $150. The food is $3 for every person, and we don't know how many people we're inviting. That's the X. So the food will cost us $3 times however many people come to our party, or however many people we invite, and that needs to equal 300. So to solve this two-step equation, we start by subtracting 150 on both sides, leaving us 3x equal to 150. Divide both sides by 3. X is equal to 50. So the maximum number of guests we can have is 50.